proportion. Okay, without much ado, let's begin. First, we'll start with proportion. Okay, for proportion, we're starting with proportion. Okay, now in proportion, we're going to look at the types of proportion and the meaning of proportion. Proportion is actually the relationship that exists between two quantities. Relationship that exists between two quantities, in which one, maybe when one quantity increases, the other one might likely increase. When we have such scenario, when one quantity increases, it affects the other one and makes the other one to also increase. Such relationship is called direct proportion. It's called direct proportion. Whereas in another scenario, when one quantity increases, the other one decrease, or the increase of one causes the other one to decrease, such proportion is known as inverse, or what you call the indirect or inverse proportion. Is that okay? So these are the types of proportion we have. Relationship between two quantities, such that when two quantities increase simultaneously, the increase in one affects the other one to also increase. Such proportion is known as direct proportion. And when one increases, the other one decreases, we call it inverse proportion. Okay, so these are the two types of proportion. Now let's take a look at an example of a direct proportion. In a factory, when you say workers are paid based on the number of poultry pots they produce, so when they produce more, they get more money. That's a direct proportion. When they produce 10, let's assume the cost of one is $1. The cost to make one is okay. Let's say $0.1 to make one pot is $0.1. So if he makes 10, he will get. You multiply this one by 10, so you get $1. If you make 100, you multiply this one by 100, you get $10. Okay, so this is a direct proportion. One quantity increase, the increase affects the other one. So the more you make, the more money you get. Now let's take a look at a real example. A bottling machine fills 500 bottles in 15 minutes. Okay, it does 500 bottles in 15 minutes. How many bottles will you fill in 1.5 hours? Okay, here there are two methods of doing direct proportion, of doing proportion. One is the ratio method, the other one is the unitary method. Okay, under the ratio method, we're going to make a ratio of the two quantities. First one is bottle and time. You can say bottle and time. So I will make a ratio of B and T, a ratio of bottle and time. So the first machine makes 500 bottles in so number of minutes. So we must make the unit to be same, in 15 minutes. 500 bottles in 15 minutes. 500 bottles in 15 minutes. Then they say how many bottles does it make in 1.5 hours? So we don't know. We can put X, number of bottles we don't know. We can call it X. It makes X bottle. We don't know the number. We're going to find it. In 1.5 hours, you must change to minutes. Remember, time must be same unit. You cannot leave it in. You cannot write 1.5 here. So you have to change it to minutes. 1 hour is 60 minutes. 1 hour is 60 minutes. So we keep note of that. The half hour is 30 minutes. Half hour is 30 minutes. So half an hour is 30 minutes. So we write another 30 minutes. So 1.5 will now be, we add these two together, we get 90 minutes. 1.5 hour will give us 90 minutes. So that's how we get 90 for the time, for this other time, which is 1.5 hour. Okay, we write 90 minutes. We write 90 minutes into that place. So we come here, we write 90. Because 1.5 hour is equivalent to 2 hours is 220 minutes. So remember, the unit must be same, minutes. If you're using minutes, you use minutes also here. You convert this time to minutes. So we've converted 1.5 hour, we got 90 minutes. So now if you make it a ratio, so I can say 500 over like a ratio of B. You know, this is if you want to put the ratio in fractional form, it's like B over T, right? If you want to put the ratio in fractional form, it's like B over T, right? Bottle over time. So that will be equivalent to what? Now let's make it the first one. The first bottle, 500 bottles were done. What was the time? 15 minutes. So I'll write 500 over 15 if I want to make it. Okay, 500 over 15. Or you just cross multiply. You just say this times this equal to this times this. It's the same thing, okay? But we're just illustrating it in a ratio form. So you say 500 over 50 is equal to the other one, bottle over time. What is the number of bottle? We don't know. We say x. So we say x over, what's the time? 90 minutes. 90 minutes. Okay, so once we have this, then we can cross multiply. We still come back to the same thing, right? We still come back to the same thing. So if I cross multiply, I will say 50 times s, I will get 15x, right? We'll get 15x. If you cross multiply, you get 15x is equal to 500 times 90. 500 times 90. 500 times 90. And 500 times 90, to do it, you just say 9 times 5. Without a calculator, you just say 9 times 5, 45. Then you add these 3 zeros. So you get 45,000, right? So x will be 45,000 divided by 15. So make s the subject. You say x equals to, you already multiply this, you get 45,000. 45,000 divided by 15. So we're going to divide it by 15. 45,000 divided by 15. So when we do that, if we want to do that, how many times 50 can go into 45? 3. 50 here, 1. 50 go into 45, 3. Because 50 plus 50 is 30, plus another 50 is 45. So 3. So the answer will be 3,000. Right? So we get 3,000. So it means, when you get 3,000, what does it mean? It means you fill 3,000 bottles in 1.5 hours. The machine in the factory will fill 3,000 bottles in what? In 1.5 hours. Because they asked us how many bottles will you do in 1.5 hours. In 1.5 hours, the machine would have filled 3,000 bottles. So this is a ratio method. When we use ratio method to solve proportion. When we are using ratio method to solve a proportion, this is what we get. Is that okay? Now, the same problem we can use the unitary method. The same problem we can use the unitary method to solve. Now, to use the unitary method is this one. To use the unitary method, let's change so that it will not be exactly the same. Let's use this purple. Now, to use unitary method, what we do? We say, remember 15 minutes, you fill 500 bottles. So we can do that one here. For unitary method, you say, in 15 minutes, a machine was able to fill what? 500 bottles. Then you now say in 1 minute. Why they call it unitary? Unitary means one. You know, unitary means one. Okay, in 15 minutes, the machine was able to fill 500 bottles. Because that's what the question says. The question says a bottling machine fills 500 bottles in 15 minutes. So you say in 15 minutes, this machine is able to fill 500 bottles. In 15 minutes, this machine is able to fill 500 bottles, right? In 1 minute, how many bottles will it be able to fill? In 1 minute, how many bottles will this machine be able to fill? It will fill 500 divided by 50. It will fill 1 minute. If you want to know for 1 minute, it's always what is here divided by what is here. So you say 500 divided by 50. 500 divided by 50. So in 90 minutes, you know, 1.5 hours is 90 minutes, right? Remember that. We already do. I don't want us to go through that again. We already converted that. Because they say in 1.5 hours, how many bottles will you fill? So in 1.5 hours, which is equivalent to 90 minutes, it will be 500 over 15 times 90 times this 90. 500 over 50, this one 1 minute that you already designated. 500 over 15 multiplied by 90. In 90 minutes, you multiply by 90. If they say in 150 minutes, you multiply by 150. So it depends whatever they've asked here. So in 90 minutes, we multiply by 90. So when we multiply this by 90, 500 divided by 50 times 90, we will still get 3,000 bottles. We will still get 3,000 bottles will be filled in 1.5 hours. In 1.5 hours, 3,000 bottles will be filled. It's okay? So this is how we solve ratio using proportion, using ratio method. Here you pause the video, please. Pause the video, like, subscribe, and share. And watch and try to lay your hands in this. A machine prints four books in 10 minutes. You can see another one, 4 books in 10 minutes. how many will it print in 2 hours? 2 hours, you must convert it to minutes. That's 120 minutes. So, okay, so 4, you do book to time. You do a ratio of book to time. You do book to time. So you say 4 to 10. 4 to 10, and then you do any of the methods. So pause the video and solve as we've gone through example. Now let's take a look at other example. Few more examples. You say tin. This is an element. Okay, tin and copper. These are elements, are mixed in the ratio of 8 to 3. So they've given you. We're going to use the ratio method. You already have tin. For the one that comes first, take the first ratio. The substance that came second, we take the second. The one that comes second, take the second ratio. So this will be copper. So T to copper, if you want to put it in fractional ratio, you say T to copper, ratio T over copper will be what? 8 to ratio 3. 8 to ratio 3. 8 over 3. In fraction, if you are putting it in fraction. Okay, this will be equal to, now we read the question further. This will be equal to how much tin, they are asking for tin, we don't know. So you can call tin Y. We can call tin Y, right? We don't know. How much tin, so I call tin Y. How much tin is needed to mix with 36 grams of copper? So copper is 36, so I put 36 here in that of copper. You know copper is at the bottom. So you put 36 for copper. So here we cross multiply. 3 times Y, we get 3Y. 3 times Y, we get 3Y is equal to 8 times 36. Okay, you can, if you don't want to write, if you don't want to multiply it, you write it out first. 8 times 36. Okay, 8 times 36. Then to find Y, you say 8 times 36, which is 288, right? So we say Y equals to 288 divided by 3. Or you just write it, 8 times 36 divided by 3. 8 times 36 divided by 3. Okay, if you want to simplify it yourself. 3 here, 1. 3 to 36, you get 12. So 8 times 12. You get 96, right? So here we get 96. Y equals to 96 grams. So there will be tin, we have 96 grams. There will be 96 grams of tin that will mix with 36 grams of copper. Okay, because it was ratio 3 to 8. So it will be 96 grams of copper. So questions like this will come for direct proportion. So you can pause the video and attempt to solve this question. You pause it here, like, share, subscribe and share, and solve these questions. We have a lot of them for you to practice to master this. Now let's go to how to divide a quantity in a given ratio. A quantity in a given ratio. This one we did this in chapter 5. I think we already understood this concept. We will say divide 20 meter or 20 m in the ratio of 3 to 2. Okay, divide 20 in the ratio of 3 to 2. So first we write the ratio out and we find the sum of the ratio, right? We find the sum of the ratio. Sum of the ratio will be 3 plus, the sum of the ratio will be 3 plus 2, 3 plus 2, 3 plus 2, which is 5, right? Which is 5. Now we want to know, because you are dividing this into this ratio. So for ratio 3, we want to know what ratio 3 we get. So for ratio 3, let's assume ratio 3 is for someone. This ratio 3, if you want to know what you will get, you say 3 over 5. 3 over the sum of ratio times the whatever you're dividing. If it's 20 million, because they just say M, could be million, could be meter. Okay, let's say it's 20 million. How many million will this guy get? The one with ratio 3. So 5 goes into 25 here, 1. If you're not using calculator, you can always cross numbers out when you're doing multiplication. 5 goes into 24. 4. If you know multiplication, many things are easy for you in mathematics. So 3 times 4, you get 12. So it means the person with ratio 3 will get 12 million. 12 million. If it's meter, it will be 12 meter. Okay. I'm just saying million for fun. Okay. Now the other guy with ratio 2, it will be ratio 2. His will be 2. His will be 2 over 5. 2 over 5 times 20. Times 20. 2 over 5 times 20. 5 here 1. 5 goes here 4. 2 times 4. This 2 times 4 we get 8. So it gives us 8 meter. So this ratio 2 we get 8 meter if you divide. So this is how we use the ratio method to divide the things. We can also use the unitary method. Okay. In unitary method, ratio 3 to 2 gives 5 parts, right? 5 parts equivalent to 20. If you want to use unitary method, you say the 5, the sum of the ratio, have the whole 20 meters. Have the whole 20 meters. One part will be what? In unitary, you must always do 1. When you express the total that is given to you, gives the total amount, what you say for one part, we give what? 20 divided by 5. Will be 20 divided by 5, which is 4. One part will be 4. 20 divided by 5, which is 4. Right? So for one part or one unit ratio, you get 4. For 3 units, now depend on which number of unit. For 3 units, it will be 4 times 3. For 3 units, it will be 4. To be 4 times 3. For 3 units will be this 4 times this 3, or this over this times 3. You get 12. You see, you still get the same answer. You get 12. We get the same answer, right? As in when we did it using the ratio method, 12 meter. If you're looking for 2 units, it will be 2 times 4, right? It will be 2 times 4, which is 8. Because once you get one part, you say one part is already 4 meter. 2 parts will be what? 4 and 4. That's 8, right? Which is 8 meter. 3 parts will be 4 in 3 places. That's 12, right? 4 parts will be 16. 5 parts will be the 20. The 5, which is the total ratio, will be 20. Is that okay? So that's that for this question. Now the last but not the least for this type, before we move to the next one, the inverse proportion. We say a factory produces car in red, blue. You know, factory, when they make car, they have to color them, give them different color. Red, blue, white, green. In the ratio of 7, 5, 3, and 1. So they don't make many white cars. Or green. Okay, green is the last one. They don't make many green cars. That's why the ratio is just 1. Out of the production of 48,000 cars, how many are white? So you look for where is white in the list. First one is red, second one is blue, third one is white, which means the third number is white. White is 3. So first you add all the ratios together. 7 plus 5, 12, plus 3, 50, plus 160. So the sum of the ratio is 16. The sum of the ratio is 16. So we have 60 as our total ratio. Okay, so if you want white is 3. So for white cars, if you want to know how many white cars were produced in this factory, we say white, the ratio is what? 3. So you say 3 over 16, multiplied by the total number of cars that were made in the factory, which is 48,000. Multiplied by the total number of cars that were made in the factory, which is 48,000. Okay? So if you cut 16 and 16, that's 32. Plus another 16, that's 48. So 16 go here, 1. 16 go into 48, 3. So this becomes 3,000. 3,000 times 3 will become 9,000. So there will be 9,000 white cars made. There will be 9,000 out of 48,000. The white cars will be 9,000. If you want to find for red, it's the same thing. Red is what? The first one, right? Red is the first one. So the first ratio is for red, 7. You do 7 times 3,000, because we already divided 48, divide by 60, we got 3,000. So you just say 7 times 3, 21. So red cars will be 21,000. There will be 21,000 red cars from this total number, because this is equal to 7 over 16. We already know if 60 divide 48, we get 3. We already know it's 3. Okay, we already know it's 3, so we just say this 3 makes this one 3,000, because this one goes here 1, this one goes here 3 times. So 3, it means 3,000 times 7, we get 21,000. How you do without calculator? Just say this 3 multiplied by 7, that's 21, and then you add the 30 in front. So most of the time we don't use calculator. If you're very good with maths, you don't need calculator in many questions, except you are multiplying decimals. Okay, if you're not multiplying decimal or you are not dividing decimal, once you know your multiplication, the 12 from 1 to 2 times to 12 times, you do a lot of things without calculator. Okay, so we move on. Here you pause this video, like, share, and subscribe, and solve these questions. Solve as many as you can for proportion. Now we go to the second phase, which is the inverse proportion. In the inverse proportion, one quantity increase, the increase in one quantity will cause the other one to decrease. For example, speed and time. If you speed up very well, the time you reach the place will become less. They are inverse. Increase your speed, time reduce. If you increase speed, time to reach there will decrease. Okay, so this type of quantities, they are called inverse proportion. They are called inverse proportion. Now let's take a look at. Also, a good example is the manpower and the number of days to finish work. If I bring 12 people to do work for me in 4 days, if I increase the number to 20, the work will probably take like only 2 or 1 day to finish, assuming they are all working at the same rate. So manpower in the factory, you bring more people, more workers, the job will be finished. Something that you can do in 10 days, the more you increase the number of people working there, if they work at the same rate, the lesser the days. That's inverse proportion also. So let's take a look at this first example. If 8 people can pick the apple from the tree in 6 days, how long will it take 12 people? 8 pick, so for inverse, you write 8 we pick apple in 6 days. Inverse just have one straight way of doing it. Okay, 8 people pick apple in 6 days. Then you now do we normally use unitary method. One person will do it how many days? 8 people do something for 6 days. You see how it makes sense. 8, you brought a lot of people, 8 people to do work for you to pick apple in your farm. They do the job for 6 days. Assuming they are working there's an assumption here, a scientific one. Assuming they are working at the same rate. Everyone is working at the same rate. So for one person, it will take how many days to finish? You say 8 times 6. Not divide now. One person will do that job for 8 times 6 days, which is 48. So if you bring one person, you say, oh, I want you to pick apple from my farm. It will take this one person 48 days to finish the job that you brought 8 people to do in 6 days for you. It makes sense, right? So it kind of makes sense. One person will do it 48 days, because the more people you bring, the lesser the days to finish it. The lesser the people, the more the days. That's why it's called inverse. Okay, that's why it's called inverse. Now we know. He said, how long will it take 12 people? So if you increase the number to 12, of course it takes lesser days, right? How long will it take 12 people? You say 12 people will be 48 days, which took one person, divide by 12. 48 days, which it took only one person. If 12 people come to it, you divide the work. When we are working, we divide the work, right? You divide it by 12 people, and it will take them only 4 days. Meaning 12 people will finish the job only in 4 days. So the choice is yours. As a businessman, you want the job to be done faster, you bring more people and pay them. Because if you still pay one person the same amount to do it in 48 days, time is wasted. But if you build a house, You bring bricklayers or you bring workers to help you build the house. If you bring only one bricklayer or one person, it will take a very long time. The job will not move. You bring more people because you still pay per day. Per person is same price. So bring more people, bring 12, bring 20, bring 30. They will do that job in 1 week. They will finish the whole job. They will build your house to roof stage and put everything if the money is there. Okay, but if you bring one person to be doing it, it will take like 6 months, 1 year, not finished. Okay, so this is for inverse proportion. Also for speed, it says cyclist averages a speed of 27 kilometers for 4 hours. Okay, so we can 27 kilometers for 4 hours. We can say 4 hours. 4 hours gives 27, or 27 kilometers give 4 hours, or 4 hours is the same thing. 4 hours, the speed it took was 27 kilometers per hour. 27 kilometers per hour, because speed 27 kilometers per hour. Now, at what average speed will she need to circle to cover the same distance in 3 hours? So 1 hour you will cover what? 27 times 4. 1 hour you do for you. We always use unity. 1 hour. This one in direct proportion, you know, we divide. We say this divide by this. But for inverse, we don't divide, we multiply actually. You say 27 times 4. Please take note. That's the only thing you need to know. In inverse, you just multiply them. 27 times 4. Because it will take one person 27 times 4 times to reach the same average speed. So for 3 hours, in 3 hours, it will be 27 times 4 divided by 3. 27 times 4 divided by 3. 27 times 4 divided by 3. Divided by 3. Okay. Why I say most times you don't need calculator. Now you can just say 3 here. 3 divided by 3, 1. 27 divided by 3, 9. 9 times 4, 36. See, you get 36 kilometers per hour. Without calculator, you get 36 kilometers per hour. So the speed in 3 hours, he must have increased the speed. If he wants to reach the journey, same destination. If he wants to reach it in 3 hours, remember when he was moving with 27 kilometers per hour, when he was moving with 27 kilometers per hour, it will take him 4 hours to reach there. But if he increases the speed to 36 kilometers per hour, it will take him what? Only 3 hours to reach there. It makes sense, right? It will take, but increase speed, he will reach there faster. The journey will only take him 3 hours because he has increased the speed. If he increases the speed to 50 something, maybe 2 hours it will take only. So the more you increase the speed, the lesser the time. That's why it's inverse. Okay, so at this point, you pause the video and try, like, share, subscribe, and try to solve all of these questions. Pause it and be solving question by question. Okay, to see whether you got it. Now let's go to increase or decrease by a given ratio. Increase or decrease by a given ratio. Say a photograph is 12 centimeters wide and 8 centimeters tall. Like, let's assume this is the photograph. Let's assume this is the photograph. It's 12 centimeters wide and 8 centimeters tall. 8 centimeters tall. It's 12 centimeters wide and 8 centimeters tall. Now it is enlarged in the ratio of 3 to 2. It's enlarged. Why is it enlarged? If it's reduced, it will be 2 over 3. But 3 to 2, because if you divide 3 over 2, it is 1.5, which means it's enlarged. It is enlarged with ratio 3 to 2. What are the dimensions of the enlarged photograph? Now, each side, you multiply by ratio 3 over 2. Okay? You multiply by this ratio 3 over 2. If you want to know the dimension of the... So if I want to know the dimension of the new enlarged one, 12 centimeters, if I want to see the new size, to be 12 times 3 over 2. Times 3 over 2. 3 over 2, 2 go here. 1, 2 go here. 2 into 12, 6. So 6 times 3, we get 80. So this is a large size. The length that was 12 before, the large one will be 80 centimeters instead of 12. The width is 8, so you say 8 times 3 over 2. 8 times 3 over 2. 8 times 3 over 2. 2 here, 1. 2 here, 4. 4 times 3, you get 12. So this side will be 12 centimeter. This side is 12 centimeter. So the enlarged one is now ratio 12. Is now side 12 to side 80. Is bigger than the previous one. Okay, so here is 80 centimeter the length, and the width or the height is 12 centimeter of the enlarged one. Okay, so this is how to solve use ratio, increase and decrease ratio to solve problem. Now this is for the increase one. Let's see if we have example for a decrease. Okay, let's see an example of a decrease if there's any. It's a photographic transparency 5 centimeter wide and 3 centimeter tall is projected onto a screen. If the image is 1.5 meter wide, calculate the ratio of the enlargement. Let's take it again. A photographic transparency, the English looks a bit suspicious. A photographic transparency 5 centimeter wide and 3 centimeter tall. Okay, this transparency, whatever, photographic film is 5 centimeter wide and 3 centimeter tall and is projected onto a screen. So it's projected, is shown on the screen. If the image is 1.5 meter wide, the image, now you can see the image, so you have to convert 1.5 meter to centimeter. 1.5 to change to meter to centimeter, you multiply by 100, become 150 centimeter, right? So the image is 150 centimeter wide. So the image, meaning the image is very big. See, the image is very big, 150 centimeter wide. The image is 150, not 5. 150 centimeter wide. Because they must be same unit. Why did we convert? Because this is 1.5 meter. Remember, the original size was 5 centimeter. Meter and centimeter cannot be. You have to convert the meter to centimeter. Right? So we convert to centimeter, become 150 centimeter. Okay? Say calculate the ratio of the enlargement. To find the ratio, you will say ratio of enlargement is 150 divided by 5. Okay? To find the ratio, length, to find ratio, you compare the length of this, divide by this. It's like scale factor in maths later in the other chapter. So the ratio will be 150 over 5, which is 30, right? 150. So it will be ratio 30 to 1. 150 over 5. This one, 5 here, 1. See, 5 goes to 5, you get 1. 150 divided by 5, you get 30. So what's the ratio now? It's ratio 30 to 1. The one on top is 30, the one at the bottom is 1. So our ratio will be ratio 30 to 1. Ratio 30 to ratio 1. Is it calculate the ratio of enlargement? So you just use 30 to multiply. If you want to know this side, the other one is calculate the height of the image. What will be the height of the image? You already know the ratio, right? Ratio is 30. You use the 30 to multiply 3. To know the height of this image, you say this 3 centimeter multiplied by your ratio. So you say 3 times 30, you get 90. So here will be 90 centimeter. If you want to change that to meter, you can divide each side by 100. So here will be 90 centimeter. Is that okay? So that's how we got 90 here, 90 for the height. Because once you get the ratio, you use the ratio to multiply the side. That's it. So you pause the video here, like, share, subscribe, and solve these questions. Solve all of these questions and see how good you are with these questions. Is that okay? So I think we are almost at the end. The other one is compound measure. I'll just talk about it. Here they're talking about things, like derived quantities. You wish you learned in chapter 1 in physics. Compound measure deals with quantities that are derived from other quantities. Like speed, for example. Speed, the formula is distance over time. So you can do a triangular formula for this. Assuming we want to say, we just want to use, this is not physics, this is just math. Assuming we want to say speed is s, but in physics speed is distance. S is distance, speed is v, but we just want to use s for speed in math here. So because there are students who are not science students, so speed is s, distance is d, and time is t. So in compound measure you can see here speed is distance divided by time. Time is distance over speed, and distance is speed times time. So there are three equations you can derive from, you can get from here. Okay, you use this triangular formula to be able to see the triangular formula. Speed is distance over time, time is distance over speed, and distance is speed times time. Distance is speed times time, speed is distance over time, and time is distance over speed. So three equations we can get from here. There's another one for density. Density is mass over volume. Volume is what? If you want volume, will be mass over density, and if you want mass, okay, density is mass over volume. Volume is mass over density, and mass is density times volume. You must know these three equations. They are always used. Now we go to population. Population density is population over area. This is in geography. Population density is population divided by area. Now if you want area, you say population over population density. If you want population, you say population density times area. So these are called compound measure, things that has formula in science, in maths, in physics, where you can just solve. So here the examples are just to solve based on the formula. Say a train travels a distance of 140. They give you a distance, they give you a time of 1.5 hours. 1.5 hours is same as 1.5 hours or 90 minutes. Okay, but you keep it the same, kilometer and hour. So calculate the speed. If you want speed, is distance divided by this. So this will be 140 divided by 1.5. 1.5 means 1.5. Okay, divided by 1.5 hour. So if you say 140, if you press your calculator, divide by 1.5, you get 93.3333. So you get 93.3. So I'll just say 0.3. If you 3 will keep repeating itself. 0.3 kilometer per hour, and 3.3 kilometer per hour. So these are easy things, and they are in physics, they are in maths, so you can easily relate. Okay. Now let's move on. If you give another question, if the average speed is 120 kilometers, calculate how long the journey takes. How long it takes? They give you a new speed, and they give you time, right? They give you, there was something again, it's a continuation of where they stop. They give you a new time and so on and so forth. Then you just use the formula. Time is distance over speed. The distance has been given to be 140, and then the speed is 120. You divide, you get this time. Okay, so these are compound measure, and there are many of them. You can pause the video, like, share, subscribe, and solve all of these questions. Okay, so I think these are student assessment. Pause this video, solve as many as possible questions, and become the person you are meant to be. So with this, we come to the end of today's class, and thank you for joining us.